Alright, hey guys, it's me again, Miss Moncrief, and I'm just trying to help you out with our new lesson. So we've been through factoring, so we're now going to look at some specific patterns. Before we do that, let's take a look at these four real quick. So we want to recall factoring as the reverse of the distributive property. So let's look at the distributive property when it comes to binomials. So we want to multiply each of the following and then write as factors equal to a product. So remember, when we have x plus 3 squared, we have to write it out twice. We have x plus 3 times x plus 3. And then we'll just FOIL. So what's x times x? X squared. X times 3 would get us 3x. And then we got another 3 times x, which would get us 3x. And then 3 times 3, which would get us 9. Now, don't forget, if we have like terms, we need to combine them. So we do. We have 3x plus 3x, which would be 6x. And that leaves us with x squared plus 6x plus 9. Alright, and let's do it one more time. Over here with this x minus 4, of course, first we need to write it out twice. So x minus 4, that's not a 4. X minus 4 times x minus 4. So let's start with first, what's x times x? X squared. X times negative 4 gets us negative 4x. Negative 4 times x gets us another negative 4x. And negative 4 times 4 gets us positive 16. Oh my gosh, I forgot the x squared. The x times x is x squared, so that's why that's x squared. So, and do we have any like terms we have? Yes, we have negative 4x and negative 4x, which ultimately give us negative 8x. We have x squared minus 8x plus 16. Oh my gosh, this pen does not want to write today. So yeah. Alright, now let's take a look at the bottom when we have 2x plus 7 times 2x minus 7. So first, let's do 2x times these. We don't have to write anything out extra again. We just need to distribute. FOIL. So it's 2x times 2x. That's right, it's 4x squared. And then 2x times negative 7 gets us negative 14x. 7 times 2x gets us positive 14x. And 7 times negative 7 gets us negative 49. Now, do we have any like terms we can combine? Yes, we have negative 14x and 14x, which is really just 0, so we don't need them anymore. Which means we are left with 4x squared minus 49. Alright, and now we have x minus 5 times x plus 5. X times x gets us x squared. X times 5 gets us plus 5x. Negative 5 times x gets us negative 5x. And negative 5 times 5, oops, forgot the x. And negative 5 times 5 gets us negative 25. Alright, do we have already anything we can combine? Yes, we have the 5x and the negative 5x, which is again 0, so we don't need them, which means we're left with x squared minus 25. Interesting. Look, I wonder if any of you have made some observations about what might we be looking at today. Alright, so let's talk about perfect squares. Perfect squares is the product of anything multiplied by itself. Perfect squares can be numbers, variables, monomials, or binomials. So let's take a look first at our first block. Let's look at when it's just numbers. So when we have numbers, we know that 1 and 4 are perfect squares, but 2 and 3 are not. That's because 1 is equal to 1 squared and 4 is equal to 2 squared. There's nothing we can multiply by itself or square that'll get us 3 or 2. So let's list all of our perfect squares from 1 to 225. First, we obviously got 1, and then we got 4. Now, some of you might be thinking, how do you get these? Well, 1 is the product of 1 squared, right? 4 is the product of 2 squared. So what's 3 squared? 9. 4 squared would be 16. 5 squared, we got 25. Let's keep listing. 6 squared, we got what? 36. 7 squared, we got 49. 8 squared gets us 64. 9 squared gets us 81. 10 squared gets us 100. 11 squared gets us 121, which is my personal favorite. 12 squared gets us 144. 13 squared gets us 169. 14 squared gets us 196. And 15 squared gets us 225. I point these out because they will be like our most used ones. So if you like come across these numbers, remember, oh yeah, they're perfect square. Let me fix it. 36. There we go. All right, now let's look at monomials. So we probably never thought of a monomial being a perfect square, so let's look at them. One example is 4x squared. Pretty much a monomial is perfect square. It means you have a perfect square, coefficient and then a variable that's squared. So let's look at the next one. We have 25a squared. What squared gets us 25? Well, that's 5 squared. And then, of course, we got a squared. What about 36y squared? What squared gets us 6? 36. 6 squared, and we got y squared. 49, what squared gets us 49? 49x squared. What squared gets us 49? 7 squared, and then we got x squared. And the 169r squared, what gets us 169? 13 squared and r squared. All right. Now let's look at binomials. Rewrite each perfect square as its factors. So like right here when we have x plus 3 squared, we really know that is x plus 3 times x plus 3. And again, we have 5x plus 7, or 5x minus 7. 5x minus 7. Oh my gosh, why am I forgetting the last number today? So 5x minus 7 times 5x minus 7. And the same thing applies, even when we have stuff like this. We have negative 3x plus 8 squared. So the factors of that will be negative 3x plus 8 times negative 3x plus 8. And we kind of saw these earlier today when we were multiplying those. We were actually starting to FOIL them. Alright, so let's look at this one. There are a couple, we've looked at factoring where we did the snowflake method and all that good stuff. Well, there's a couple of patterns we can notice. So the first pattern we have is called a difference of squares. Now, for it to be a difference of squares, it has to have 3-ish kind of things, okay? First, it has to have squares. That means it has to have perfect squares. So it's got to have perfect squares. That means the first number, that means the first term has to be a perfect square, and the last term has to be a perfect square. And difference, what do you think that is? That's subtraction, so it has to have a subtraction sign in the middle. Middle, oh my gosh. And then take a look at what we have when we have perfect squares. We were given this we were given this a squared x squared minus b squared. We were given that. How many terms, because this is what we're going to factor, how many terms does this have? It has the first one and the second one, so it also has to have two terms. Two terms only. Like a president. So let's look at the first one. We have 9x squared minus 1. Now first off, let's see. Are my two terms a perfect square? Yup. Yup. Is there a subtraction sign in the middle? Yup. Are there only two terms? Yep. Really, you could probably move the third point up because that would be the easier one to look at. But yeah, those are the three things this will have. So what we're going to do here is just take the square root of the first one, the square root of the last one, and have a positive one and a negative one. So let's start with, what's the square root of 9x squared? Well, first, what's the square root of 9? 3. And then the square root of x squared would just be x. So we got 3x. And now, what's the square root of 1? You're right, it's 1. So that means we'll have 3x plus 1 and a 3x minus 1. So essentially, we'll take the square root of the first one, the square root of the last one, set up two parentheses, one with a plus sign in between them and one with a minus sign in between them. Pretty simple. So let's look at B. Is 16x squared a perfect? We got 16x squared minus 49. I'm going to check 3 first. Are there only two terms? Yes. Is there a subtraction sign in the middle? Yes. And are these two a perfect square? Let's figure it out. Are they on our perfect squares list? 16 is, so that's cool. And you know what? So is 49. So I think this is going to work out. I think this is a difference of squares. So let's go ahead and start. Let's take the square root of first. What's the square root of 16x squared? Well, what's the square root of 16? 4. What's the square root of x squared? X. And now let's take the square root of 49. What can I multiply by itself twice to get me 49? 7. So that means I'll have 4x plus 7 times 4x minus 7. Sounds cool. All right, let's keep going and do these last two. So let's check it. First off, is there only two terms? Yeah, we have 25x squared minus 64. There's only two. Is the sign in the middle a subtraction? Heck yeah, it is. And now we need to check, are these both perfect squares? Well, let's see. 25 is a perfect square. Lit. 64 is a perfect square. So I think this is going to work out. So we'll take the square root of the first and the square root of the last. What's the square root of 25x squared? Well, what's the square root of 25? It's 5. Square root of x squared, as we've seen twice before. It'll just be x. And then what's the square root of 64? It's 8. So that means we'll have 5x plus 8 and 5x minus 8. So far, so good, right? All right, now let's do the next one. We have 81x squared minus 121. First off, is it only two terms? Cool, it is. Second, is the middle sign subtraction? Once again, it is. And then lastly, are these perfect squares? Is 81 in our perfect squares list? And is 121 in our perfect squares list? Yes, it is. I even told you that one was my favorite. All right, so let's take the square root of the first one. What's the square root of 81? That'd be 9. What's the square root of x squared? That'd be x. And then what's the square root of 121? It's 11. So that means we have 9x plus 11 and 9x minus 11. All right, so that's difference of squares. Alright, so we are now going to look at the pattern called perfect square trinomials. So, perfect square trinomial. So let's start off with looking at kind of defining a perfect square trinomial. Obviously, it has perfect squares, so we know it's going to involve perfect squares. And then a trinomial just means it has 3 terms. So the important thing here is look that if it has 3 terms. One of the important things. 3 terms and some perfect squares in there. Perfect squares. Ugh. Alright, y'all get the gist. Perfect squares. So those are kind of the 2 things it'll need to have. But one other important thing is that it has no leading coefficient. That just means a is going to be equal to 1. So what this is saying is that x squared plus bx plus b over 2 squared. We're just saying that half of b squared is going to be c. C is going to be half of b squared. And the same thing goes for x squared minus bx plus b over 2 squared. It'll still be c is half of b squared. And what it'll look like, it'll just look like x plus that b over 2, all of it squared, or x minus that b over 2, all of that squared. What matter is the sign of that b. If it's positive or negative, that will be our answer. So let's look at our first one. We have x squared plus 18x plus 81. So what we want to do here is look at b first. So b is definitely 18. We want to see what half of b is. So what's 18 divided by 2? Well, that is 9. So now I want to make sure that 9 squared is actually 81. So what is 9 squared? Well, that is 81. So since c is half of b squared, then we can work this. So we'll just do a parentheses, x. What's the sign in the middle? Positive, and then we'll use that half of b, which would be 9. And all of that squared. So how do we know that this is right? Well, we'll FOIL it out. So we can do x squared, or x plus 9 times x plus 9. And what's x times x? Well, that's x squared. What's x times 9? 9x. What's 9 times x? Another 9x. And what is 9 times 9? Well, that is 81. And then let's combine some like terms. What's 9x plus 9x? Well, that is in fact 18x. So it works out. Look at that. So we are left with x squared plus 18x plus 81. Alright, now let's try it on b. So we have x squared minus 20x plus 100. Well, let's see if 100 is half of b squared. So let's take b. What is b? b is negative 20, and what's half of that? Well, that is, in fact, negative 10. And then, so let's see if negative 10 is actually 100. So we have negative 10 squared, which is 100. So this one will work out. So again, we'll take our parentheses and we'll do x. We'll do the sign that's in the middle, negative. And then what is that half of b? Well, that's 10. So we got 10 and all of that squared. So that's one way to kind of do it. And let's look at another way. So one way to always kind of check this out, I'm erasing some of this so I have room, is we can also just do this. Let's take the square root of the first. So what's the square root of x squared? Well, that's x. And what's the square root of last? Well, that's 1. So we'll do x and 1, and then we'll just take the sign in the middle, which is plus, so plus and square it. So that will leave us with x plus 1 squared. Now we do want to check it. One way to check it is to FOIL it. So let's FOIL it. So we have x plus 1 times x plus 1 And what's x times x? X squared. So x times 1, that would be just x. 1 times x would be another x. And 1 times 1 would get me 1. So do we have terms we can combine? Yes, we have x and x, which will leave us with x squared plus 2x plus 1, which is what we got originally. Another way you can check it still is to, when you do this square root x and then square root the c, check. See if this is half of what b was. Is 1 half of 2? Yeah, so it'll work out. All right, now let's do the next one. Again, we want to take the square root of the first. What's the square root of x squared? Well, that is x. And now we want to take the square root of 56.25. Now, that's not we don't normally do that, but we can in this case. So second square root of 56.25, and what do we get? 7.5. Now let's actually see if 7.5 is half of 15. So what's 15 divided by 2? Well, that is 7.5, so this is going to work out. So then we'll have x, what's the sign in the middle? Minus 7.5. And then we'll square it. So yeah, that's two ways to figure out factoring perfect square trinomials. You can either divide b and square it to make sure that that's c, and then do x plus or minus whatever you got when you divided b by 2. Or you can take the square root of the first, square root of the last, and take the sign of the middle. So yeah, that's perfect square trinomials. Now let's take a look at one more example before we go. So now we are wanting to look at fully factoring. We are fully factoring quadratics. A quadratic is fully or completely factored when the GCF is factored out and the remaining trinomial is factored into two binomials. So all this is doing, we're doing the same factoring we've been doing for all the other lessons, but now we have a GCF. Now we have a greatest common factor. So here's kind of a checklist we go through. First, is it in standard form? So that means, does it look like ax squared plus bx plus c? Next, is there a GCF? Is there a number that can easily divide into all of the other ones? And then third, is there a difference of squares? Or perfect square trinomial, either one. So let's look at this first one, A. We have 24x squared plus 96x plus 90. So those are all relatively large numbers, so we first need to find the GCF. Now, let's find the GCF by doing this nifty little calculator trick. So let's put them in there. Go to your y equals. Put them in order. So we have 24, 96, and 90. Do 24 in y1, so 24 divided by x. Do 96, y2 in y2, so 96 divided by x. And then lastly, do 90 divided by x. So put all of those in your y1, y2, and y3. And now let's go to second graph. So it brings us up to a table, and now we just got to figure out what we need to now we just got to figure out which one's my GCF. So what we're going to do is we're just going to scroll down and see what is the highest number that has all whole numbers. So 1, we got all whole numbers. That could be our GCF. 2, we have all whole numbers, so definitely not 1. 3, we have all whole numbers, but do we have more? Let's see. 4, we don't have all whole numbers. 5, we don't have all whole numbers. 6, we have all whole numbers. 6 is looking promising. 7, we don't. 8, we don't. 9, we don't. 10, we don't. 11, 12, we don't. 13, we don't. All right, it's looking like there's not going to be any other numbers other than 6 that counts for our GCF. So what we need, so that means 6 is definitely going to be our GCF. So we know that 6 is our GCF between the 3. Now, one thing you can do is go ahead and divide all of those by 6. So divide 24 by 6, 96 by 6, and 6 by 6. And that will get you 6, because that was our GCF, times 4x squared, because 24 divided by 6 is 4. And then 96, and plus 16x squared, because 96 divided by 6 is 16. And then 90 divided by 6 is 15. So that's how we got that. Or, if you look here, because we put them in order, it does have to be put in the order A, B, and C. We could have just done 6. And then what did I get in y1? 4. 4x squared plus, what did I get in y2? 16. Oops, forgot the squared. 16x. And plus, what did I get in y3? 15. Always remember divide, just because you know that would be, just because you know how to do, just because that's what we're doing is dividing. But if you put them in the right order, the calculator does it for you, which is, the calculator kind of has it in the order that you need it to be in. All right, and then the next thing says factor the trinomial we have. So we have 4x squared plus 16x, sorry, plus 5. Now, definitely not a difference of squares, because a difference of squares has to have two terms, all right? Is it a perfect square trinomial like we just checked? Well, we have a leading coefficient, so it's that's not 1, so it's not. So now we just have to go ahead and do it the old-fashioned way and factor it with our snowflake. So if you remember, A times C is in top, and B is in the bottom, and we have AX and AX. So what's my A of my new trinomial? Well, that's 4, so we have 4 times, what's C? That's 15. And then let's go ahead and figure out what's 4 times 15. 4 times 15 gives me 60. Over, what's B? 16. And lastly, we have the AX. So A is 4, so 4x and 4x. All right, and now let's still do our calculator trick in order to find the numbers that will multiply to get a 60 and add to get a 16. So go to y equals, clear out everything you've already put in so you don't confuse anything you've done with that. So we have 60, that's not 60, 60 divided by x, and 60 divided by x plus x. And click second graph, and now we want to go to where we find b in y2. 19, 17, 16. So what are my 2? It's 6 and 10. Now remember, you got to see if there's a common factor between these numbers. So what's the common factor between 4 and 10? Well, that's 2. So divide both those by 2, which leaves us with 2x and 5. And then do the same thing here. Do we have a common factor between 4x and 6? Yep, it's 2 again. So what's 4 4x divided by 2? Well, that's 2x. And what's 6 divided by 2? 3. So that leaves us with, don't forget your GCF, 6 times 2x plus 5 times 2x plus 3. And that's cool, right? I think it's cool. I hope you guys do too. Alright, now let's look at B. B, we have negative x squared plus 9x minus 18. Now, you might be sitting there at home or wherever you are thinking, that doesn't have a GCF. But remember, what is always a GCF? Always. It's a negative. So let's go ahead and take out the negative. So what's negative x squared divided by a negative 1? Just x squared. 9x divided by a negative 1, well, that's negative 9x. And negative 18 divided by a negative 1, well, that turns into a positive 18. Now let's see if we have some of our patterns. So first of all, is this going to be a difference of squares? Well, no, it's not going to be a difference of squares because we have how many terms? 3. Now, could it be a perfect square trinomial? I don't know. Let's check it out. What's the square root of x squared? Well, that's x. What's the square root of 18? Aw, man, you can't take the square root of 18. So, it's not a perfect square trinomial either. Let me just backtrack all of that. So now that we know it's not a different squares and it's not a perfect square trinomial, we're just going to have to go ahead and do it the old-fashioned way. So again, our snowflake. I don't know about you guys, but I love the snowflake method. So much better than what I learned in high school. So in the top we'll have 1, which is our A, times 18, which is our C, which would get us 18. In the bottom we'll have our B, which is negative 9. And on the side we'll have 1x, because 1 is our A, and 1x, because they're the same. Alright, and now let's find a number that will multiply to get numbers that will multiply to get us 18 and add to get us negative 9. To get us negative 9. And let's do that with our fun little calculator trick. Oh my gosh, the amount of calculator tricks you guys are learning, I wish I knew them when I was your age. So we have 18 divided by x, and then 18 divided by x plus x. And go ahead and click enter. Well, click second graph to get to the table. Oops. Alright, and now we need to go find negative 9. So far, I don't see her and y2, and all those numbers in y2 are getting bigger, so let's go up. Ah, there she is, negative 9. So that means we got negative 6 and negative 3. And negative. And negative 3. So, let's check those. Is there anything that can go into negative and 1x and negative 3? Nope. Anything that can go to 1x and negative 6? Nope. So that means we still have our so that means we have our two binomials. So go ahead and bring down the GCF, the negative, so negative. And then we have x minus 3. And now we have x minus 6. And there we go. There's our answer. We have fully factored a trinomial. Whoa, I'm so proud of us. We have fully factored a trinomial. It's a beautiful day. Alright, now let's go check out the next one. We have 15r squared plus 141r minus 90. All those numbers are so big. Let's see if they have a GCF, because I don't want to try to do all of this with all of that. So clear out the calculator, because you got other stuff in there and you don't need it anymore. So again, go in order of A, B, and C. What is my A? My A is 15, so we'll do 15 divided by x. Next, what is my B? My B is 141, so we'll do 141 divided by x. And lastly, what is your C? Well, it's negative 90, not just positive 90. Make sure you include the negative. Negative 90 divided by x. And now we'll click second graph and find the highest x value that has all whole numbers and all the y's. So let's go check it out. 0 has an error. We don't want to look at negatives here because none of these are negative. Well, we don't want to look at negatives here because the leading one is a negative. So 1, obviously. Let's keep going. 2's not going to work out. We got 2 decimals and a whole number. 3, we got some whole numbers here. I like 3. 4, all decimals. 5, 1 decimal. 6, couple decimals. Oh no, I'm afraid 3 is going to be our only hope. So 3, let's go ahead and bring that 3 out then. Now remember, we can really just divide by 3, but let's go ahead and take what our calculator gave us. We have 5 in y1, so r squared, 47 in y2, so that's what got us 47r, and negative 30, so that's what got us minus 30. Alright. So now that we have that, let's see. Is this a difference of squares? No, it's not, because there's not 3 terms. First of all, there's not 2 terms. There's 3 terms. So Is it a perfect square trinomial? No, because 5 is not a perfect square and neither is 30. So now we just got to move into our snowflake, our lovely, lovely snowflake. Alright, I'll slow down a little bit on the snowflake in case anyone forgot it. So remember, what two numbers go in here? Go on their top. That's A times C. What goes in the bottom? B. And on the sides we have A, X, and A, X. So remember, it's AX squared B plus BX plus C. So that means anything with the squared variable is our A. So what's our A? 5. So we have 5 times, what's C, the constant? Negative 30. Let's go ahead and multiply those. What's 5 times negative 30? You got it. That's negative 150. All right, and now let's put B in the bottom. What's my B? That's the one in the middle, which would be 47. And now let's put our AX on the side. So 5. And instead of having X now, we have R. So let's include R so we don't forget what variable we're using. So now I need a number that will multiply to get me negative 150 and add to get me 47. So let's go to y equals and figure it out. So we'll do negative 150 divided by X and negative 150 divided by X plus X, and we'll do second graph to see where we're at. So let's go find 47 in that y2. Now we're all at negatives in y2, so let's just go down, see what happens. Our numbers are getting bigger, so that's positive. Ooh. Ah, there it is, almost past it. So what numbers do we have? We got negative 3, and we got 50. We got negative 3 and 50. So let's see if we have anything that can simplify. Can we simplify 5r and 50? Yeah, 5 will go into both of those. What's 5r divided by 5? R. And what's 50 divided by 5? 10. Now we have 5r and negative 3. Can either of those simplify? No. So now we can go ahead and write our completely factored form. Bring down your GCF. What was it? 3. And then we'll write out our two binomials. So we have r plus 10 and 5r minus 3. And there you go. So, now that we've done those, let's check out our last two. We are almost done with this video. Let's check them out. So first of all, we want to know what is our GCF. Well, right, let me say the problem first. We have D is 12x squared minus 48. First of all, we want to know what's the GCF between 12 and 48. So go to your y equals, clear it out because that's not what you have there. And let's do 12 divided by x and 48 divided by x. And now let's go look at that table. Alright, so it might take me a minute but because of the last problem got me down into the 40s on x. So let's just kind of go up to 0 and start from there. Oh my gosh, I'm so sorry. I didn't think about that when we did this. Alright, so 0's got its error, as always, because you can't divide by 0. So let's see, what's the highest number that gets us two whole numbers? 1 has its two whole numbers, that's always reliable. 2's got its two whole numbers, that's nice. So does 3, and so does 4, but let's keep going, just to double check. 5, no, both decimals. 6 has got its two whole numbers, so that's looking promising. 7, no. 8, no. 9, no. 10, no. 11, no. Okay. Ooh, 12. We got 12. I almost lost hope there. 12 has its two whole numbers. Let's keep going. Maybe. Nope, I think 12 is it. I think 12 is definitely it. So we have 12. So what are... So that means we can divide both of them by 12. So let's do that. So we have 12, and then what's 12 divided by 12? Well, that would be 1, so 1x squared. And then what's negative 48 divided by 12? Well, that would be 4, or negative 4. Oh my gosh, you can't hear it, but there's people laughing out in the hallway, and I'm just so confused. Anyways, moving on. So we've got the GCF. We've got that all figured out. So now we want to see, is it a difference of squares? Could it possibly be a difference of squares? Well, it is two terms, so let's, I don't know, let's check it out. Can we take the square root of x? Oh my gosh, we can. What's the square root of x, or the square root of x squared? That's x. And can we take the square root of 4? Well, yeah, that's 2. So this is a difference of squares. Yay! So we can bring down the 12. And then we can do x plus 2. And we can do x minus 2. That is so exciting. And because it's so exciting, we're done. Now, isn't that cool? Now let's look at E, everybody. Let's look at E. So E has negative 12x squared plus 27. We already know for a fact that negative's out. So let's go ahead and take it out like we know. So we're left with 12x squared plus 27, right? So we got that. Now let's find the GCF between 12 and 27. Maybe some of you already know it. So clear out your calculator because we don't want that stuff. So we have 12 divided by x. And now we have 27 divided by x. So second graph to get it to show us. And again, I'm sorry, it's not already at 0. Alright, so now we're at 0. Error as usual. 1, 2 whole numbers, reliable. Oh no! Alright, 2, not 2 whole numbers, not reliable. We don't like 2. 3, 4, and 9, that's some 2 whole numbers. We like 3. 3 is our top choice right now. 4, we got 3 and 6, 75, and 5, we got 2.4 and 5.4, and 6, we got 2 and 4.5, and all those have decimals. That's so annoying. So my guess is we're going to have to stick with 3. 3 is going to be our other GCF. So that means we'll have negative 3 because we got to keep the negative. And then what's 12 divided by 3? Well, that's 4. So 4x squared plus, and then what's 27 divided by 3? 9. 4x plus 9. Now, is this 4x squared? Oops, forgot the x squared. Is this one a difference of squares? Well, no, it's not. It's not a difference of squares. I'm sorry. So we can't do that. It's not a difference of squares either because it has a, oh shoot. Oh shoot. I completely forgot to do something after I took out the negative. So let's start this one over. I'm so sorry. We'll remember some stuff, but I gotta start this one over. So, I said earlier we needed to take out, when we take out the negative, that changes everything. What's 12x, negative 12x x squared divided by negative 1? That's just 12x squared. And then what's positive 27 divided by negative 1? That's negative 27. Alright, so now let's speed through the other parts. What's the GCF between 12 and 27? I don't know. Let's plug it into y equals. Oh my gosh, it's already there. And then we'll do second graph. And let's go find it. All right, what's the highest number that has all whole numbers? 3 is looking promising. All right, it's 3. We know it's 3. I told you it was 3 earlier. So we'll have negative 3. And then what's 3 divided by 12x? Well, that's 4x squared. And then what's 27 divided by 3? Well, that's negative 9. And now we can see if this is a difference of squares. So, is 4x squared a perfect square? I don't know. Let's take a look. What's the square root of 4? Well, that is 2. And what's the square root of x squared? That is x. What's the square root of 9? That's 3. And then is the sign in the middle negative? Yes, so this is a difference of squares. So that means we'll be left with negative 3, because that's my GCF, times 2x minus 3 times 2x plus 3. All right, so that's the end of our lesson for 8.4. I'm pretty sure, let me check, the rest might be practice. Yes, so that's the end of our lesson for 8.4. It's all about factoring and factoring patterns and making sure we learn how to take the GCF. So, don't forget the GCF. Enjoy the patterns. They make factoring easier. If you have any questions for me or your other teachers, I'm sure they'd love to hear from you. I hope you have a lovely, lovely, lovely day after watching this video, and goodbye.